Hey everyone, Tarun here, and today we are going to be talking about ternary operators in Java. So the ternary operator is a very condensed and a compact form of if-else statement. It evaluates a condition and executes the code based on that condition. So let us see. So the syntax for the ternary operator is as follows. We have a condition, and based on that condition, whether it returns true or false, we evaluate some expression. In case the condition returns true, then the first expression is executed. In case the condition returns a false, then the second expression is executed. Whatever the result of these expressions are, they are returned to the result on the left hand side of the equal to. So this is the syntax for a ternary operator. Now let us see and try it with a problem. So let's say that I have a problem as that I'm given an integer and I'm required to print whether the integer is odd or even. So we can do this with this method. So I have the integer being stored as num, and I run an if-else check. I check whether the number is divisible by 2. In case it is, I store the answer in an answer string. I have created it above over here. And if the number is even, I store odd inside it. At the end, I just print whatever I have got in my answer. Now this code is perfectly valid and correct, but there is a much more compact and a simpler way to write all of this in one line of code, that is using the ternary operator. So let's see. So this is the same functional code, but in just one line. So over here, first of all, we have the condition. Based on this condition, whether it returns true or false, we decide which expression to evaluate. So in case it returns true, then the first expression is going to be evaluated. In case it returns false, then the second expression will be evaluated. So let's see with an example. Let's say that my number is 5. So in this case, the condition expression is going to be Java. Logical operators allow us to make decisions based on some other conditions. In Java, the logical operators can be categorized into 3 categories: the AND operators, the OR operators, and the NOT operator. We'll be looking at each of these 3 in much more depth in the coming tutorials. So stay tuned and I will see you in the next tutorial. Thank you for watching. Hey everyone, I'm Tarun, and today we are talking about the logical AND operator. The logical AND operator takes in 2 expressions and returns true only and only if both the expressions are true. In all other cases, it will return a false value. The logical AND operator in Java is denoted by a single ampersand sign. So let us take an example to understand it in a better way. So let's say that I am writing a program to check the eligibility of a voter in India. The two main conditions to be an eligible voter in India are that the age must be greater than equal to 18, and two, that the person must be a citizen of India. So now if I'm writing a program to determine the eligibility, it would go something like this. So let's say that I have a variable age. Let us initialize it to 20. Let's say that I have a string which says citizenship. I'll initialize it to Indian initially. And now I'm looking to check whether a person is an eligible voter. So a person is only and only eligible if both the condition, the age must be greater than equal to 18 and the citizenship should be Indian. So I would say if age is greater than equal to 18 and, so I would denote and with the ampersand sign. And I can say citizenship must be Indian only. In this case, I can say that the person may vote. For all other cases, I'll say that the person cannot vote. So let us try to break this down. So over here, I have two expressions. This is expression 1. This is expression 2. Both of these expressions are two expressions that use relational operators to return Boolean values. So in this case, when my age is 20, the first expression is going to return a value of true. For the citizenship check, the citizenship has been initialized to Indian. So in this case, the second expression will also return a true. And it is only and only in the case when both of these values are true, this complete expression will return a true. And then this statement will get printed. So let us try it out. So if I execute this program, you can see that I get the output as person may vote. In case I reduce the age to, let's say, 15, and now I execute the program, you can see that I get the output as person cannot vote. So even if one single condition out of these is violated, the answer is false. So now let us take a closer look at this. We can see that the output or the result is only true if both the expressions are true. Now you can see that there are two cases when the first expression can be false. Now, in these cases, we can say that we do not even need to look at the second expression. We can simply ignore it, right? Because a false and anything, it could be a true or a false, doesn't matter. The result is always and always going to be false only, right? So basically we are able to infer that in case the first expression returns a false value, we don't even need to look at the second expression. We can decide our result from there and then. So for this purposes, we are introduced with the second operator in Java, that is the logical short circuit AND. The short circuit AND is denoted by double ampersand signs. It behaves the exact same way as the simple logical AND. The only difference is that if the first condition returns false, so if the first expression is false, it doesn't even check the second expression, what the value is. It returns its result from there and then it will never even bother to check this value. It doesn't care because it has got its result from there and then. However, if the first value returns a true, then it will go on to check what the second value is, because that will be the value that will decide the overall result. So the logical short circuit AND is a slightly optimized version of the logical AND. False, it doesn't and always and always going to be false only. Its value we used with the second operator in Java, that is the logical short circuit AND. The short circuit AND is denoted by double ampersand signs. It behaves the exact same way as the simple logical AND. The only difference is that if the first condition returns false, so if the first expression is false, it doesn't even check the second expression, what the value is. It returns its result from there and then it will never even bother to check this value. It doesn't care because it has got its result from there and then. However, if the first value returns a true, then it will go on to check what the second value is, because that will be the value that will decide the overall result. So the logical short circuit AND is a slightly optimized version of the logical AND. In most cases, we will be using the logical short circuit AND only because of its optimized nature. So we can change our code to use the logical short circuit AND by just adding one extra ampersand. And now when I execute this code, you can see that I get the same output because the age condition has been violated over here. Let me change this to 25 maybe. And now when I execute it, you can see that I get the output as person may vote. So in the previous case, when the first condition didn't match, what happened over here was that when this condition returned false, short circuit AND didn't even check what this expression had for itself. It didn't even bother. It simply returned overall as the result would be false only. And when we got a false, the interpreter went on to execute the else part and we got the output as person cannot vote. So that's it for this tutorial. Hope you understood the difference between the logical AND and the short circuit AND, and I will see you in the next video. Thank you for watching. Hey everyone, I'm Tarun and today we are going to be talking about the logical OR operator in Java. The logical OR operator takes in two expressions expressions and returns true if either one of those expressions is true, otherwise it simply returns false. So let us say that the first expression is true and the second expression is also true, then the result that we would get would be true. In case the first expression is true, however, the second expression is false, the result would still remain to be true because at least one of the expressions was true. Let's say if the first expression is false, but the second expression is true, then in that case, the result would still remain to be true. However, if both the expressions return false, then in that case, the final result is going to be false. So let us see it in action. So let's say that I want to write a code where I want to check the organization of a person. So let me define a string organization and initially let me just say scalar. And I want to verify whether a user belongs to either scalar or the interview bit organization. If the user belongs to either of these two organizations, I would permit the user. In all other cases, I would block the user. So I can write it as if organization is scalar or if the organization is interview bit. So if it is either of these organizations, then I must say that the user is permitted. Else, for all of the cases, I will block the user. So over here, we take the organization string and we compare it one by one with the scalar string and with the interview bit string. And if either of these two expressions return true, then the overall result would be true and this statement would get executed. So for example, for this particular example, we have the organization string as scalar. So this expression would return true, then a false. The overall result of these two would be true. So for this particular case, I should get the output as user is permitted. So if I execute this code, you can see that the output is user is permitted. Similarly, if I change the organization to interview bit and I execute this code again, you can see that I get user is permitted. So still this if block ran. However, if I change the organization to some XYZ organization and now if I execute it, locked. So this is it for the logical OR operator. Now we can see that in case when the first expression returns true, we can simply determine our result here only. We do not have to look at the second expression at all because we know that if either of the expression true only. So in case we get the result of the first expression as true, there is no need for us to evaluate the second expression. So for this, the logical short circuit OR is similar in this aspect as a short circuit AND, that it does not evaluate the second expression if it is not needed. So for this particular example, if my organization is interview bit, I can say, okay, this is going to return a false, and then we must check what the second expression has to offer. So the second expression will return true, and thus the overall result would be true only. However, let's say that the organization was given as scalar. Then in this case, when we evaluate the first expression, the result would be true. And in this case, there is absolutely no need to evaluate the second expression, because the first expression has resulted in a true, and that is more than enough for me to infer the result of the OR. And so the overall result will come out to be true only. And then I will execute this piece of code and return user permitted. So that's it for the short circuit OR. Hope you understood it. Hope you enjoyed this tutorial. I will see you in the next tutorial. Thank you for watching. Hey everyone, I'm Tarun, and today we are talking about the logical NOT operator. The logical NOT operator takes in a single Boolean operand and returns its reverse as the result. The NOT operator takes in a single Boolean operand and returns its reverse as the result. So for example, if the operand is true, it will return false. If the operand is false, it will return a true. So let us say that I have a Boolean variable and I am required to print hello world to the console if the flag is false. So I can do this as if flag is equal to false, I can print hello world to the output. However, it is generally not a good practice to use relational operators with Boolean values. So a better way to write this would be to use the NOT operator. So I can put an exclamation mark, which is the NOT operator in Java, in front of the Boolean value. And now when I execute this code, you will see that I get an exclamation mark, which is relational operator. The flag is false. So I can do this as if flag is equal to false, I can print hello world to the output. However, it is generally not a good practice to use relational operators with Boolean values. So a better way to write this would be to use the NOT operator. So I can put an exclamation mark, which is the NOT operator in Java, in front of the Boolean value. And now when I execute this code, you will see that I get the output as hello world. So basically what happened over here was that since the value of the flag variable was initialized to false, so NOT of false returned a true. So this expression became true. And thus, since it was true, the if block was executed. Similarly, if the value of flag was initially false, then the overall expression would have evaluated to false. So now if I execute this with flag is equal to true, I get no output at all. So that's it for the logical NOT operator. Hope you enjoyed this tutorial, and I will see you in the next one. Thank you for watching.